Show by the principle of mathematical induction that for all n belongings to the set of natural numbers, the following is true. How do we show this? So first we have to consider a statement. So we will suppose that let that statement be represented by P of n. So what we'll do, we'll consider P of n such that we have 2 plus 5 plus 8 plus 11 going all the way up to 3 times n minus 1. So this will be equals to n over 2 multiplied to 3n plus 1. So all we have done is we have converted the given equation into a statement form. So let's call it statement number 1. Now we need to verify that whether if P of n, this statement is true for all n belonging to the set of natural numbers. Means any natural number that we pick up, this equation must be true. So let's verify that. So we will first consider n to be equals to 1. That means we'll consider the first natural number. Now in that case, P of 1 such that what we get here is the first term only, because n equals to 1 corresponds to the first term. This being a series. So 2 is going to be equals to 1 over 2. We're replacing n with 1 multiplied to 3 times 1 plus 2. So 2 will be equals to, so 3 plus 1, that's 4. 4 divided by 2, that's going to be equals to 2. Fine. So here we have shown that this simply means that P of n, the statement P of n comes out to be a true statement. This is true. Now this is going to be true for one specific case. That means for n equals to 1. Now how do we show that it is true for other natural numbers as well? So here what we'll do, we will be considering another natural number. So suppose let n be equals to m such that we're choosing a natural number m such that the statement P of m is true. We're making an assumption here that this is a true statement. That which means that this simply means that we can now rewrite the new statement P of m as 3 plus 5 plus 7 plus 8 going all the way up to 3. We had 3n minus 1, but we will replace that n with m to get 3m minus 1. So this is going to be equals to m over 2 multiplied to 3 times m plus 1. So let's call it statement number 2. So here we are saying that for a new natural number m, the statement P of m, let that be a true statement. And using this statement, we'll need to show that the next consecutive number to that of m. So P of m plus 1 such that we have 3 plus 5 going all the way up to 3m minus 1 added to. Now what we'll do, to get the next term, we have to replace this m value with m plus 1. So that gives us 3m plus 2. This must be equals to, now on the right hand side of statement number 2, we're going to replace m with m plus 1. So we have m plus 1 divided by 2 multiplied to 3 times m plus 1 added to 1. So we need to verify that this particular statement is also true. If m is true, then P of m plus 1 must be true. So how do we show that? All we have to do is consider the left hand side of the statement of Pm plus 1. On the left hand side, we have 3 plus 5 plus 7 plus 8 going all the way up to, we have 3m minus 1 and we have 3m plus 2 added to it. Fine. However, luckily for us, we can replace this with m over 2 multiplied to 3m plus 1. Now, why have we replaced it with this particular expression? Because in statement number 2, we have already assumed that P of m is a true statement, which means that summing 3, 5, 7 all the way up to 3m minus 1 must be equals to m over 2 times 3m plus 1. So that's what we have done here. This is going to get added to 3m plus 2. Fine. Now what we'll do, we're going to combine these two terms. So let's do one thing. So we have a common denominator of 2. In the numerator, we have 3 times m squared added to m, added to 6 times m added to 4. Fine. So that means we now have 3m squared plus 7m plus 4. Right? Divided by 2. Now 3m squared plus 7m plus 4, we can split the middle term and factorize it. That should give m plus 1 multiplied to 3 times m plus 4 whole divided by 2. But we can rewrite 3m plus 4. So that means we now have half multiplied to m plus 1. So 3m plus 4, we're going to rewrite it as 3 times m plus 1 added to 1. Now, as we can see, we have obtained exactly what we needed here. So we have m plus 1 over 2 multiplied to 3 times m plus 1 added to 1, which means that this is indeed the right hand side. So we will say here that since the left hand side matches with the right hand side, so our given statement must be true. So that means P of m plus 1 must be true. And we have been able to show that this is a true statement based on the fact that the term previous to that of m plus 1, which is m, was originally true. So now what we can do, hence we can generalize it. We can generalize it and say that P of n, the original statement P of n, is true for all natural numbers n. That means for all values of n, for all values of n belonging to the set of natural numbers n. That means any natural number that we pick up, the statement P of n, this statement is going to be always a true statement. So we have successfully used the principle of mathematical induction to verify our problem.